Dear students, welcome to the class. In the class, we are going to discuss the nature of the quadratic form. So, what is the quadratic form? Quadratic form is that homogeneous second degree equation in n number of variables or any number of variables. That is called the quadratic form. So, what is the nature of the quadratic form? Nature of the quadratic form is what is the rank, what is the index, what is the signature, and then nature, whether it is a positive or negative or combined of positive and negative. Okay, now we will discuss one by one. So, see the first point. When the x transpose Ax is reduced to the canonical form, it will contain only R terms. It will contain only R terms if the rank of A is R. So what is the rank of R? What is the rank of R? If you are finding the eigenvalue, of the matrix, the number of non-zero eigenvalue is the rank of the matrix. In case if it is a symmetric matrix, at least one of the eigenvalue is 0. Therefore, the rank will be reduced. So, the number of non-zero eigenvalue, it may be positive or negative, that is not the problem. But number of non-zero eigenvalue is the rank of the matrix. Okay. Then, if the rank of the matrix is 3, for the 3 by 3 matrix, you are finding the eigenvalue. In case if you are finding the eigenvalue of A, in case 3 non-zero eigenvalues are there, then the rank of the quadratic form is 3. And one more thing, when you are reducing from the quadratic form to canonical form, you will get that 3 terms. In case the given matrix is the singular matrix, at least one of the eigenvalue is 0, then the canonical form contains only the R ranks. That means, in case one of the eigenvalue is 0 means 2 other eigenvalues are there. So, canonical form will contain that only 2 terms. That is the first point. Second point. The second point is index. The number of positive eigenvalues or number of positive terms in the canonical form. Actually, we are going to form the canonical form based on the eigenvalue. Since x transpose Ax, this x transpose Ax is going to convert into canonical form. When you are going to convert into canonical form, you are converting a matrix into the diagonal matrix. What are the elements of the diagonal matrix? These are the eigenvalues of A. Is it not? So, based on that only we are going to convert into the canonical form. Therefore, second point is the number of positive terms in the canonical form is called the index of the quadratic form and it is denoted by P. Otherwise, we can say that the number of positive eigenvalues is the index of the quadratic form. That is one thing. See the third point. Third point is signature. Signature is a very simple formula. It is denoted by S. Small s equal to 2p minus r. 2 into number of positive eigenvalues minus number of terms in the canonical form. So, this is the signature of the quadratic form. Next, we are going to find that the quadratic form is in n variables if it is said to be positive definite, then there are n variables. It is the quadratic form is the n variable quadratic form. Then the number of terms in the canonical form is R. The number of terms in the canonical form is R. So, if R equal to n and n equal to p, the meaning is, what is R equal to n? R is number of times in the canonical form, and N is the number of variables. N is the number of variables. So in case if it is an quadratic form in 3 variables, we will get that 3 by 3 matrix. 3 by 3 matrix. For the 3 by 3 matrix, we will get that 3 eigenvalues. 3 eigenvalues. If all the and one more thing, 3 eigenvalues are non-zero. 3 eigenvalues are non-zero. So 3 eigenvalues are non-zero and all the eigenvalues are positive. See that n equal to p. Number of variables is n and then p is the number of positive eigenvalue. So if all the eigenvalues are positive and then the matrix is not the singular matrix, then it is called the positive definite. Second one point is positive semi-definite. Positive semi-definite. It is very easy to understand. Semi means half. So at least one of the eigenvalue is 0. One of the eigenvalue is 0 and then see that R is less than n. So the number of times, in case any one of the eigenvalue is 0, the number of times in the canonical form will be reduced. Therefore, positive semi-definite if R is less than n and P equal to R. Very simply we can say that the given matrix is the symmetric matrix. Third one, negative definite. Already I explained about the positive definite. If all the eigenvalues are positive. Here just quite opposite of the negative definite. If all the eigenvalues are negative. If all the eigenvalues are negative. And then there is no non-zero eigenvalue. There is no non-zero eigenvalue. Then only you will get that R equal to n and P equal to 0. If all the eigenvalues are negative, then P equal to 0 only. That means index is 0. There is no number, there is no positive terms in the canonical form. Okay. So fourth one is negative semi-definite. Negative semi-definite is all the eigenvalues are negative and one more thing, at least one of the eigenvalue is 0. At least one of the eigenvalue is 0. Once again, if that matrix is singular matrix and the eigenvalues of the singular matrix are negative. Okay, at least one of the eigenvalue is 0 and then remaining eigenvalues are negative. So then we will get the negative semi-definite. Then last one, indefinite in all other cases. Indefinite in all other cases. All other cases mean here everything is positive, here everything is negative. In case all the eigenvalues are both positive and negative, then the quadratic form is said to be indefinite. Okay, so just now we discussed about that. What is the rank of the quadratic form? What is the index? What is the signature? And what is the nature? So this combinedly is said to be the nature of the quadratic form. In the next class, we are going to discuss problems in the quadratic form to canonical form. Okay. See you in the next class. Thank you.